Hello everyone, I'm Zhang from Department of Computer Science, Rice University. Today I'm going to present on continuous local search for hybrid SAT solving, a joint work with Anastasos Kourtidis and Moshe Vardi. The problem we are aiming to solve is called Boolean constraints and satisfiability, or SAT in short, where every variable is from the Boolean domain. We will deal with a bunch of different kinds of Boolean constraints from CNF XOR to cardinality constraints. We want to design a solver which can give a solution of a system consisting of Boolean constraints. SAT has a lot of applications, for example, solving combinatorial problems, probabilistic inference, motion planning, as well as software verification. The current SAT solvers have a drawback, which is they cannot handle different types of constraints uniformly. Our previous work called SAT is a framework of solving Boolean satisfiability with a continuous method, where we transform the Boolean formula into a multilinear polynomial, and then we compute the gradient so that we can apply gradient descent to find a minimum. After that, we just discretize the minimum to see that if we find a solution. Our previous work has a drawback, which is the gradient on the real domain is expensive to compute. To address that issue, we use binary decision diagrams, or BDDs, to replace the polynomial and accelerate the gradient computation by using a message passing algorithm on BDDs. As a result, the gradient is now as cheap as evaluation, and our tool can accept more types of constraints, for example, pseudo-Boolean constraints. We tested our tool on a bunch of different kinds of SAT and MaxSAT instances. And in summary, our tool is good at handling cardinality and pseudo-Boolean constraints, as well as small-size MaxSAT problems. On the other hand, we also observe that our tool has some limitations of handling large and XOR-rich instances. If you are interested in our work, please come to my Q&A session. Thank you.